Hello everyone, and welcome to our video on the introduction to polar coordinates. So the polar coordinates are a different coordinate system where we measure or plot a point by using an angle and a distance. So often we still will draw like an XY axis to do our problems. However, the way that a point gets plotted, let's just put a big point right here. In the polar coordinate system, we would say that this is r comma theta, where the length from the origin to that point would be r, and the angle in standard position would be theta. Okay, so instead of measuring a horizontal distance and a vertical distance, we're measuring an r and a theta. So a length, so r like a radius. So they like r for radius of a circle, but it's still just a length from the origin, and then we rotate it whatever the angle says to rotate it. So to plot our points here, so let's plot this one in blue. So plot the following polar points. So here we have 2 and pi quarters, and then this is a way to show the polar coordinate system if we have technology or if it's already printed out. It's so nice for us, but we again usually just draw x, y because it's faster. But what we've got here are circles that are radius of increasing by 1. So here we do have a radius of 1, a radius of 2, 3, 4, and then 5. So those are the radii of those circles there. And then what we want to do in these problems, we really start with the angle. So we know our angle we've got right here would be pi sixth, pi quarters, pi thirds, and so forth, pi halves. So we start with the angle, and we usually draw either a solid line or a dashed line. I'm going to do a dashed line through that angle, and notice I had to go both ways all the way through, so I drew the whole line. And then from that, we'll count our distance of 2. So we always do the angle first and then the distance second, or the radii second. And we just count on the circles. Okay, so 1, 2. So it's right there. I'm just making it extra big. Okay, so that's how we can plot these. So again, we measure an angle and then we count however far we need to go. Oops, let me erase that. Okay, so for our second one on this same coordinate system, we have the first graph the angle or line through the angle. All right, so pi thirds. Notice they often still use our nice unit circle angle. So here's where 2 pi thirds would be. And I just drew a straight line all the way through, or a dashed line. And then now I just need to measure a length of 3. Okay, so going to the 2 pi thirds, I would go 1, 2, 3. Like that. Okay, so those are the 2 points marked right there. All right, so for number 2, this time instead of drawing all those circles, I'm just going to draw a big old horizontal and vertical axis. And we'll plot these. I'm going to do this first one in blue as well. Okay, so negative 5 pi 6. Let's show it with the little arrow or the little arch angle like that. Okay, so it's still, so negative angle. So it still follows the same old rules as always when measuring something in standard position. And then what I'm going to do is measure or plot a line through that. Okay, so here was the negative 5 pi 6th angle. And then since I don't have any circles already drawn on this, I'm just going to do tick marks and say, well, here's 1, 2, 3, 4. Okay, so there's our point then, 4 and negative 5 pi 6th. All right, so let's see number 2, or the second point they want us to plot. All right, so on the second one, again, we measure the angle first. Okay, so measuring pi would be over here. And then I'm going to draw in a line to show that angle. Okay, and then going toward the angle that we plotted, doing my tick marks would be 1, 2, 3. So they should be about the equally spaced like the blue one was. Okay, however, this is 1, 2, 3, and so forth. So if I kept going, 4. All right, however, in our problem, we have a negative value, -3. Well, this is why I drew the whole line in these problems. If going toward the left in this scenario are positive values, then that means going toward the right would be negatives. So we would have -1, -2, -3. And that's where our point would be plotted in this problem. And then -4 and so forth if we needed it. Okay, and just to mark the blue line, so I said that this is a length of 1, 2, 3, and it might even help to put the angle instead of the arch where the ray was headed toward. That way we can see, okay, so if it's a positive value, it heads toward that angle that we plotted. If it's a negative value, we would have gone in the opposite direction. So this would have been the -1, -2, -3, -4, so forth. Okay, so if we plot those lines out, we can figure out positive versus negative. Okay, so let's see one more plotting. All right, so this we've got plot the polar point, and then we'll find two other polar points that are equivalent. Okay, so let's get this right here. And I'm going to measure that angle. Okay, so -3 pi halves, and it might even be better to just say, well, here's my angle 0. Here's where negative pi halves would have been. Here's negative pi. Here is -3 pi halves. Okay, so I'm going to draw a line through the origin going to 3 pi halves, and then I'm going to keep it going the other way as well. Okay, so going toward the -3 pi halves angle would be +1, 2, 3, so forth, 4, 5, 6, 7, 8. But in this problem, we need a negative, so we should go the opposite way. So -1, -2, -3, -4, 5, 6, 7, 8. Okay, and let me change my color so we can see it. So that is where that point is plotted. Okay, so this is the point that we plotted, the -8 and -3 pi over 2. Okay, so that's the final official answer down there in the big bold point. But then it does say find two other polar points that are equivalent. Okay, so let's use, I'm going to do purple first. Well, I could have gone this way right away. So I could have looked at the negative pi halves. And with the negative pi halves, then that means, so if I'm headed toward negative pi halves, it would have been considering these points as positives. 1, 2, 3, 4, all the way to 8. Okay, so that means another point, if I do the negative pi halves, then I should do a positive r. Okay, so this is one of the other points that we could have done. Okay, so I chose to go clockwise to get it real quick. Or I could have gone, let's do it in green. I could have gone in standard form with a positive angle all the way around, or not all the way around, but around to the negative y-axis, and then that would have been the angle 3 pi halves. And if I'm headed toward 3 pi halves, then again, these would be positive values just like they still are in the purple. So that means our radii should be 8, or our radius should be 8, and the angle would be 3 pi halves. Okay, so there's another way we could have gotten the point. We could continue to just add 2 pi to those angles. That's another thing we could have done. Okay, so let's mark that. Could add 2 pi to angles for more terminal points, for more, let's say, more polar points that are equivalent. Okay, because we know the properties of the unit circle, it just goes around and around forever every 2 pi. Even here, we could have added it to that one. So one other point would have been -8 and positive pi halves. Okay, so that's it, if we wanted to keep the radius negative. Okay, because that would have mean we would have been right here. Here's positive pi halves. Going up toward, let's even put it next to the blue, going up toward pi halves would have been positive values. So then I should go the opposite way to get negatives, which is that big old point down there that we wanted. Okay, so that's how we can graph these. So again, it's always the angle first and then measure a distance. If it's a positive distance, go to the angle that was plotted. If it's negative, go the opposite way. Okay, thanks for watching. If you have any questions, please let me know.